Introduction. This assignment provides a comprehensive analysis of statistical data to evaluate the relationship, reliability, and predictive capabilities of various variables. The primary objective is to explore how the independent variable IVS influence the dependent variable DV through a combination of descriptive statistics, reliability tests, correlation analysis, and regression modeling. Objective. This task is to comprehensively analyze statistical data to evaluate relationship, reliability, and predictive ability of various variables. The main objective is to explore how to independent variable IV affect the dependent variable DV through a combination of descriptive statistics, reliability tests, correlation analysis, and regression modeling. Research theory. In this study, we use for C theory 3 independent variable IV and 1 demographic variable DV. We are select because they are related to the study. The variable manipulated or controlled by the researcher to observe its effect on another variable. The first independent variable will select grab location proximity. Grab location proximity features utilize GPS and mapping technology to determine the distance between user and service provider, such as drivers or delivery personnel. This feature ensures efficient matching by connecting user with the nearest. The second independent variable, we are select user demographic for Grab. The user demographic for Grab is diverse, encompassing individuals from various group, income level, and demographic location across Southeast Asia. Its primary user include young professionals, students, and families who rely on its service for transportation, food delivery, and logistics. Urban residents are a significant segment, given Grab's strong presence in cities where convenient and quick access to service are highly valued. Additionally, the platform appeals to tech-savvy individuals who prefer app-based solutions for daily needs. Grab also caters to small business and entrepreneurs offering tools and services that support their operation. The third independent variable, we also select pricing of Grab. Grab pricing strategy is dynamic and varies based on factors like service type, demand, distance, and location. For ride fare, calculated using a base rate plus distance and time charge, with price ranging during peak hour or high demand. Food delivery price include delivery fees that depend on proximity and order size. Grab frequently offer promotion, discount, and subscription plan, such as Grab Unlimited, to provide cost saving and attract loyal users. This flexible pricing approach ensures accessibility while maximizing revenue in competitive market. Lastly, we also select the demographic variable DV about acceptance of Grab among students. The acceptance of Grab among students is driven by its convenience, affordability, and accessibility. Students often rely on Grab for quick and reliable transportation, especially in urban areas with busy schedule or limited public transport option. Features such as share ride, discount, and loyalty reward appeal to their budget-conscious nature. Additionally, Grab user-friendly app and integration with cashless payment method make it easy for tech-savvy students to adapt. Grab food delivery service also cater to their lifestyle, offering a wide range of options and flexibility. This factor contribute to high acceptance and users among the student demographic.
AG group. This group has a mean of 3.9875 and a standard deviation of 7.4422. This suggests that the average value in this group is around 3.99 and the data points are relatively spread out around this mean. JL group. This group has a mean of 3.8042 and a standard deviation of 7.1617. This indicates that the average value in this group is slightly lower than the AG group, and the data points are also relatively spread out. UDOG group. This group has a mean of 3.8333 and a standard deviation of 8.3319. This group has the highest standard deviation, suggesting that the data points in this group are more spread out than in the other group. PG group. This group has a mean of 3.8625 and a standard deviation of 0.5671. Similar to the UDOG group, the data points in this group are also relatively spread out. IV1 Chrome Batch Alpha 0.398. A value of 0.398 indicates low internal consistency among the 4 items. This suggests that the items do not strongly correlate with each other or measure the same construct effectively. Such a low value is below the generally accepted thresholds for a reliability scale. N of items equal 4. The scale includes 4 items. The small number of items could partly explain the low alpha value, as fewer items generally result in lower relativity. IV2 Chrome Batch Alpha equals 0.617. A value of 0.617 falls in questionable relativity range. While this is improvement compared to very low reliability 0.5, it still suggests that the scale has moderate issues with internal consistency. It indicates the 4 items have a modest correlation and may not fully align in measuring the item construct. N of items equal 4. The scale includes 4 items, and the relative low number of items could contribute to the lower relativity. Typically, adding more items can increase relativity if they measure the same construct. IV3 Chrome Batch Alpha 0.791. A value of 0.79 falls in the acceptable to good relativity range. 0.7 considered acceptable, 0.8 more A, 0.9 is considered good. It suggests that the 4 items are sufficiently correlated and effectively measure the same underlying construct. N of items equal 4. The number of items relatively small, yet the alpha value is high enough to indicate reasonable internal consistency. V. AG and GL correlation 0.445. Moderate positive relationship. AS AG increase, GL tends to increase, and the relationship is statistically significant. AG and UDOG correlation 0.04. Strong positive relationship. As AG increase, UDOG also tends to increase. AG and PG correlation 0.737. Strong positive relationship between AG and PG. GL and UDG correlation 0.523.
Key analysis. Model summary. Model 1. R for Model 1 is 0.770. This is the multiple correlation coefficient. It indicates the strength of the relationship between the observed and predicted values of the interdependent variable AG. A value closer to 1 signifies a stronger relationship. R square is 0.593. This represents the proportion of variance in the dependent variable AG that is explained by the independent variables, which are PG, GL, and UDOG. In this case, 59.3% of the variance in AG is explained by the model. Adjusted R square. The next ANOVA. Sum of square for ANOVA. Regression 19.372 represent the variation in the dependent variable explained by the regression model. Residual 13.306 represent the variation in the dependent variable not explained by the model. Total 32.678. Total variation in the dependent variable, which is the sum of the regression and residual sum of square. Mean square. The mean square is calculated by dividing the sum of square by its corresponding degrees of freedom. Regression 19.372 divided by 3 equals to 3.457. Residual 13.306 divided by 56 equals 0.238. The significance. The significance is lower than 0.001. This is the p-value associated with the F statistic. The p-value less than 0.05 indicates that the regression model is statistically significant. In this case, the predictors collectively have a significant effect on the dependent variable. Hypothesis testing. For this case, we are using 4 hypotheses, which are number 1, one sample t-test. One sample t-tests are used in the report to assess if the mean answers to a particular question variables deviate significantly from a value that has been hypothesized often zero. Results that are significant p-values less than 0.05 show that the test value and the observed means are different. 2. Correlation. Correlation is a statistical measure that describes the strength and the direction of the relationship between two or more variables. When the two variables are correlated, it means that the changes in one variable are associated with changes in another. Correlation helps to identify patterns in data and is useful for predicting trends or understanding relationship between factors. 3. Regression analysis. Regression analysis, a statistical technique that used to model and analyze the relationship between one or more independent variables and a dependent variables. The main purpose of regression analysis is to understand the relationship between these variables and make predictions or inferences based on the data. 4. Analysis of variance or ANOVA. ANOVA, a statistical method used to test if there are any statistically significant differences between the means of three or more groups. It helps determine if the variation within the groups is different from the variation between the groups, which will indicate that the group means are not all equal.
In conclusion, this study examined the factor influencing the acceptance of Grab service among students. Focusing on location proximity, user demographic and pricing strategies, the finding revealed that this independent variable significantly impacts student satisfaction and users of Grab with location proximity, enhancing service convenience, diverse demographic, driving engagement, and dynamic pricing, fostering affordability. Statistical method, including one sample t-test, correlation analysis, regression modeling, and ANOVA, confirm the predictive power of this variable and provide robust insight into the relationship between them. The study highlights the importance of data-driven decision-making for optimizing business strategies, offering valuable guidance for Grab to refine its service and strengthen its position in the competitive market.